Okay, Rushii, welcome to the podcast, and thank you for kind of joining us. We just continue where we kind of left off when we met last time, and I think the first thing that's sitting on the viewers' minds is where are the scooters, right? So we kind of been hoping that production has happened, and when will delivery happen, and So can we kind of have some thoughts on the delivery and production schedule for the Glides?
Sure. I think so. As you guys already know, we launched in almost 9 months ago in January. We had a launch event, and obviously you guys also covered a little bit of content on that. Also, we had a podcast that was happening, at least 2 or 3 months back. So I think what has happened is that we being a technology company, it has been a curve for us to the supply chain, because it's 98% localized, right? So we have around 27, 28 or tier 1 OEMs who are supplying components to us. So it's a nightmare in terms of managing these supply chain issues and teething issues. We don't want to give you a half cooked almost production aligned versions during the launch, during the track day that happened just 3 days back. So I think you would have also faced that there are some minor teething issues that are still being ironed out before the vehicles start going to the customers. As early as January is when we want to start dispatching the vehicles to them. Also, the vehicles that you guys test through just 3 days back are also going to be sent across to for the dealers, distributors who are going to also start giving out demo test rides for their performance and other showcasing of the vehicle to the dealers, to the pre-book vehicles, pre-bookers and stuff like that. So I think December end is our timeline for the dealers, distributor demo vehicles dispatch, and January start to mid is when the pre-ordered customers are going to start getting their vehicles already being delivered, through our distributor dealership networks. So I think January is a good, timeline to show across the vehicles to the customers.
Absolutely. Okay, and whenever you're doing a resale market, they always ask you which year the vehicle was produced, or sold in. So 2022 sound much better than 2021. So right, it's always resale value zyada milega.
It's always better to have it on the first half of that year. Yeah, you are so right.
Yeah,
but no, our agenda was not that. Our agenda for the delay was not that. But it apparently was a good point to go
on. Okay. So, Rushii, when you kind of grow older, there's one problem. You end up asking the same questions again and again. So I probably have asked this question to almost every manufacturer that I have met. I'm going to ask the same question. NMC versus LFP, what's your take? You decided to go in for NMC, and we'd like to understand what your rationale was and how you're going to ensure that you get a good warranty on the battery when it comes out. So, over to you.
So I think I told you there are few aspects to this question. It's not only about why NMC over LFP, right? So we are not favoring any particular chemistry or anything else. It's just the matter of 2 or 3 things. One of them being the supply chain reliability, right? So if you look at the LFP market today, it's so saturated with cheap Chinese stuff, and you don't end up seeing the quality difference because you're using it in a cheap Chinese scooter. So when it comes to we being using these batteries made NMC or LFP, when it comes to putting these things on a heavy performance scooter, you would have driven it and it goes to 90 kilometers per hour top speed. So when these vehicles are being run, a lot of power is being drawn from these things, and that's when these cells are being tested, their capacities and their quality. So I think we wanted to make sure that we don't end up buying cheap labeled cells. There are LFP obviously, and then end up using these vehicles, and then tomorrow the performance goes down, or maybe the performance doesn't even come out as expected. You want to make sure that supply chain is good enough. So currently, what is happening is that, to be very frank and to be very open, NMC cells have been used in the international markets, especially China, Taiwan, Korea, for almost 12 years now. So it has reached a point of an inflection where the cost is obviously a parity, is using a parity point, but also at the point of time, it's also the supply chain is very reliable now. So if you know where to get the components or the cells from, you're not going to make a mistake of the LFP dilemma that people are facing today. Because LFP, where there are 2 or 3 brands, and then they are rebranding it and getting into India, a lot of commotion is happening there in terms of the trade that is happening. So, but in case of NMC, if you have a stable supplier from China or Korea, where our cells currently come from, it is a point where what is going to be coming to you. Now, coming to the life cycle, obviously there are trade-offs. But then we have our algorithms that are taking care of it. So, as we mentioned at the track day also, we are already working on very heavily, trying to enhance the lives of the battery packs. And also the range degradation is very low as compared to, different chemistries that we currently have. So I think with our tech on it, and also the reliable suppliers we currently have in terms of NMC, we are overlooking at least a year's time before we switch to another chemistries. But having said that, you would never know if the chemistries have been changed, because we seal our battery packs. Only the serial number would tell you. Only we would know what cells have gone into your battery packs. But having said that, we'll definitely keep on iterating our quality of the battery packs over a period of time. But then having said that, it's very clear that we want to make sure that our reliability in terms of supply chain is good at this point of time, because when we're scaling up our production, we want to make sure that the supply chain also can support us in that matter of fact. So that is one thing. Second thing, as mentioned, technology is good enough to support any chemistry as of now, and we can give you good life. And third, obviously, being the form factor, right? So if you look at the battery packs we have limited space on the vehicle to put in more batteries. So you would definitely know LFP is a little safer and it has its pros, but the cons is that it's a little less energy dense. So you end up, using more area to get the same amount of power in the same, form factor. So I think at the end of the day, it's the trade-off between size versus energy density versus, supply chain. And I think currently NMC is a better option to go about. But yeah, as I mentioned, you would never feel the difference in your battery packs, even if you change the chemistries over a period of time, because the warranties would remain the same. You would still get the same performance out of the battery packs. So it's our pain to change chemistries and warrant these things. But I think we are doing it in a way which we can warrant in the longer run.
No, so Rushii, you mentioned warranties. So I don't know whether you mentioned it on the site or not, but would you like your viewers to know what kind of battery warranties and what kind of degradation at the end of it is what you're looking at?
So I think the viewers can very well expect 3.5 years of warranties in terms of we do a zero voltage policy. So if at all at any point in time in the 3.5 years, or extended if you take a warranty of 1.5 more year, if you don't even take that till 5 years, if at all the voltage ever goes to zero or the battery stop giving you voltages, it's a clear replacement. We don't even ask you questions. There's no repair warranty or anything like that. It's a replacement warranty right now. So what happens at the end of the day is that we are warranting you against almost anything that can happen to the battery pack. That's one of the things. Second, in terms of range degradation, I think we have been able to achieve that in a very on a software side, that we have been able to on the firmware side, we have been able to make sufficient changes to not let the degradation be very evident to the user at the end of the 3.5 years, or even 4.5, 5 years. It's not going to be very evident. Yeah, talking about the degradation after 5 years is definitely going to be there. It's a fact, right? We cannot get away from that. As it's basic physics. So I think after 5 years, you would start getting at least 20% degradation in your life. But your degradation will be somewhere around 8% or so after 3.5 to 4 years. That's it. That's right.
Okay. So that's a very optimistic value, and I have not heard these kind of figures from any other battery manufacturer. So I believe there's some software jugaad magic that you're doing, and I hope viewers will end up appreciating that, because guys, 8% is phenomenal, and all the best in trying to achieve that. Okay, so moving on, Rushii, to the motors now. How do you compare on torque front? So I'll talk about the mid-drive guys now, because we'll compare apples to apples. So when you're looking at the specs for a Chetak or for an Ather or for an Ola, how do you compare in terms of power and torque? If you can just tell us about that.
So I would tell you one thing is that we are way more, energy dense in our drivetrain as opposed to anyone else currently. So I would not talk in terms of the weight versus this, but in terms of power or the efficiency versus torque output, right? So we are at a very good point currently. We give you 104 Newton meter of torque at the wheels on on the SX Plus. That's comparable to any other, above 1 lakh vehicle that's currently there in the market. Now, how we can achieve that is because of one or two few reasons. One of them very heavily being the fact that we are sourcing it from vendors who have been doing this for a long time, and for way more heavier applications than what we are using it for. So our drivetrains have been derived from stuff that could actually be a few 30-40 kilowatts easily. And so when you derive these things and you downgrade your drivetrains to be able to give you power out is obviously going to be way more efficient than when you designed it for to be. So if you design it to be a 4 kilowatt system and you draw 4.5 or 5 kilowatts, it's going to heat up and cause a lot of problems to you. But what we have been deriving these drivetrains from is a point where it has already doing a lot of thermal stresses and a lot of heavy torque applications has been used for. So I think what is happening at the end of the day is that we have been able to achieve a very good thermal characteristics also on this. So in comparison front, we are good at thermals. We are good at our overall torque delivery also. And yeah, we do a mid-drive system with a dual stage reduction. So I think it's again a stationary torque. We can actually, with the reduction in the place, we can actually play around with the speed versus torque characteristics also. So 105 Newton meter at 90 kilometers per hour is unheard of at this point of time. So,
and in terms of starting torque, Rushii, is that kind of, I thought it was a bit on the lower side because you have to rev it up a little bit to kind of get the torque. And I saw with the Ola, for example, it had a very good, zero speed torque kind of a thing. So is there something that you have kind of tinker around with on the starting torque front? Because that's one area which I would suggest we need to work on.
So there are two things to this. One is the thing that obviously the SX has a very low starting torque. Reason being, we have limited the power heavily on that to be able to meet with the regulatory approvals for that. But in the SX Plus front, I think we have a very good starting. The acceleration is very good because we have a 0 to 60 of almost 3.7 seconds, and as low as around 2.9 seconds on the dyno. So I think we are very much good on the starting torque front. But yeah, having said that, I think what happens at the end of the day is that it's not only the starting torque that always matters, right? Because also what ends up happening is that we do a lot of tuning on our drivetrains to be able to give you, good range versus performance characteristics. So we do 100 kilometers a short range, but then we are getting even way more than that as we discussed at the track day also. So I think these things have more to do with the fact that if you draw more power in the lower speed ranges, not getting as much of the work done because you are just going from 0 to whatever speeds you want to go to initially. So I think higher speed, higher torques is really what is desirable, and that's what the thing has been designed across to give you the most feels. But I think our starting torque is also good enough for any stop and go traffic. So I don't think that's going to be much of an issue. SX Plus stops it in that way. SX definitely has a little bit of a lower starting torque, but it's tuned that way to be able to give you more of a petrol type feeling to it. So I think, so stop and go traffic is not going to be an issue with both the vehicles, SX, SX Plus. But obviously, it's definitely not going to be that jerky Chinese torque that is going to be getting that you get on almost any other brands currently. So I think Ather has a very linear torque delivery, and that's what is very similar to our performance as well. But I think, definitely, it's not going to be China type torque thing that you would expect.
Correct. When I was in Bombay and we were on the test track, you mentioned something very interesting about your motor, and I have not seen other manufacturers discussing that, probably because they don't have the bandwidth in motors or whatever. But you talked about things like how do you manage flux as the speed goes up in order to kind of control back EMF. And, we try to make part of our talks as lessons in education for people who don't know so much. So to the layman, can you just tell us what this whole flux weakening business is all about? You also got it on your website. So I guess people who are going to purchase your vehicles, if they can find out what special thing that you've done on that, I think that would be nice.
So I think it's to do with the fact that the motor spectrum, the performance spectrum is not always going to be at good efficiencies when the speeds go up. So as I mentioned, speed versus torque is what we are trying to achieve at a higher speed. Now, as the torque as the speeds go to increasing, the torque will definitely decrease. That's a linear relationship between both of them. But with flux weakening, what we've been able to achieve is that at higher speeds and to give you better torque, the power delivery has to go less. So the power has to be regulated when it is higher speeds and trying to accelerate even further. So what happens is when you're going to higher speeds, right? So these are obviously sensor-based motors, they're not sensorless motors. They are sensor-based motors. So what happens is that at the end of the day, when you are going at higher speeds, there's obviously perception of vision, sort of a thing that happens in R, right? 1/6 of the second. If you have something going, you would assume that it's almost stationary. The similar thing happens at very high speeds on these motors as well with the sensors that are there already on the place. So what we do is that we try to we have an algorithm at the end of the day that actually senses these phases that are going up at very high speeds when it goes across. And then we try to weaken the amount of power that's flowing to every phase. And how this helps is that it actually helps us overall reduce the back EMFs that comes back from heavy current flows that happen at very high speeds that creates a lot of back eddy EMFs. And that's what we are trying to reduce with the flux weakening. So in very layman terms, it's basically just the fact that we are trying to limit our power at higher speeds, because at higher speeds, motor tend to draw a lot of power because it needs to go at higher RPM and higher torque. But we try to limit that torque at a specs that is going to give you good speed and also give you good performance, but at the same time not draw a lot of power and still give you a lot of performance out of the vehicle.
Right. So one of the things, one of the things that we are going to be doing once we get the Glyde for a longer trial is I want to do a highway test, and we're doing exactly the kind of thing that you're going to be talking about. So we'll take it at 70 kmph and drive maybe 100 kilometers, and see whether what kind of are we getting the range, because one of the things that happens at 70 kmph is your wind resistance doubles compared to 50 kmph, for example, right? And if your battery can sustain that kind of air friction and whatnot, then that's the real test, because a lot of people who are looking at your kind of scooter are the ones who might want to do some kind of basic intercity kind of travel, not really intercity, but longer kind of a thing, and they will never travel at 40 kmph then.
So I'll just put a bit over here. Is that all our testings are currently happening on the on between our so if you are well versed with the Mumbai geography, it is happening between our offices in Borivali to our plant in Vasai. That's almost 50 kilometers worth of a patch, and it's almost 30 kilometers worth of highway. So I think we are doing a lot of those tests that are currently going on in terms of our battery calibrations and stuff like that. So it's we are very much in that zone where we can actually promise you a lot of things. So 100 kilometers assured range is what comes from those day in day out testing that have been happening. So I think just a bit there to put across.
Because see, there are manufacturers, I will not name them, but they know that their vehicles get 100, but they claim 95 because they don't want to over promise in some sense. And the fact that you're so proudly talking of 100 gives me a little bit of confidence, right, that it will actually deliver more than 100. But again, the taste of the pudding is in the eating. We will wait for eating up the Glyde when it comes to us, and then we'll kind of comment on that once we've digested that information. Yeah, absolutely. Okay. Another interesting thing, which is about since you are again we were talking more on technology, is regeneration. And so Kamlesh and me were kind of doing test drives on the Jaguar I-Pace a few months ago, and they had a facility where you could set the regen level. So is that something which is in planning in the future? Because I believe that if a user has control on that, then I think they can play around and find out what is the most efficient mode for them and what is the kind of mode which kind of pleases them the most. So any take on that?
Yes. So to answer the question, just to clear it up, yes, we do have variable regen on our vehicles. That is currently being controlled by OT updates. We're not giving assurance as a feature as right away from the very beginning, because what's happening is that a lot of people don't know about a lot of things, right? So what's happening is if you give them a lot of information to digest, it's going to, at the end of the day, spoil the experience for them. So if at all, let's take an example where, a layman from, let's suppose, a tier 2 city and tries to get across hands on the Glyde Plus and finds the regen function. For him, it's just a scroll bar that's going to go left, right, and increase and decrease some parameter, which he doesn't even know what it means, right? So what is going to end up happening is if he puts the regen at the maximum and then starts riding the vehicle and lets go of the accelerator, it's going to start braking. And maybe he's not comfortable with that experience of that sudden braking as the acceleration goes off. So I think we don't want to make it as a thing which is going to not be known across what it even does. So for now, what we're currently doing is that we are through the phone, you have an option when you tinker around in the settings in your app, then you can do it. So it's a little hidden inside your point. So at this point of time, you can actually do 3-level regen settings on your Glyde SX Plus. Not on the SX Plus, you can do 3 levels of regen settings. But over the period of time, we actually want to have that feature directly built onto the display via an OT update. And that's doable because whatever is needed to do that, on the hardware level is already there on the vehicle. It's just a matter of giving you a UI to be able to control the same on the screen. So yeah, to answer your question, we do have variable regen of 3 different levels at this point of time. Hidden in the app would be obviously more evident as in when we think the consumer is ready to or majority of the consumers are ready to go across to a point where regen would start making more sense to them in a variable front. But yeah.
Okay, Rushii, I was hearing from the Chetak guys that they have an onboard charger like you have, and they've restricted themselves to 48 volts because I believe there are some rules which say that you can't be a high voltage guy and have a charger, or there's some separate this thing. So could you just clarify a little bit on that? Because again, like there's not too many companies which are making this offer, and you're one of them. So maybe what's the philosophy and what's the legalities about onboard chargers?
So I think the biggest, the point that is there to onboard chargers is that there's a lot of more compliances involved over and above the offboard chargers or low voltage or low power onboard chargers. Now, if you go anywhere beyond the 2.5 kilowatt, 2.7 kilowatt mark when it comes to onboard chargers, the regulations for these compliances goes exponentially high. Now, why would we choose for this is because there are two or three parameters to this. First is that our system was a high voltage system, so we could not go with a 48 volt system. Obviously, we could not charge the vehicles. We had to go for a 72 volt system. The trade-off to this was that we wanted to make sure that we do a high power system, because higher the power in terms of the voltages, lower is going to be your heating effects, lower is going to be your amperes being drawn.
So current reduces.
You can do the math. So I think that reduces a lot of complexities in terms of the thermal management with the vehicle that has to happen during charging. Obviously, we all know that majority of the mishaps are happening everywhere because of when it's charging. I would not tell you go into details, but it is because at lower the voltage, more currents is being drawn to fast charge the vehicle, whatnot, right? So we wanted to make sure we are in the higher voltage range. Now, to answer the compliances front, we were lucky enough to be able to already be compliant with most of the parts on the EMMC front on the higher voltage side of the entire vehicle architecture. So if at all you were to go for a higher power and a higher voltage system and match it with a low power system, it's a nightmare, because then you would need to have multiple compliances in place, which would be handshaking with each other, and a lot of complexities with that. But in our case, the vehicles were already compliant with 72 volt or a high voltage, high power system. And we could just manage the onboard charger with them, and the thing was done, and the compliances were not much of an issue with us. That was the one thing. Now, second is that nobody currently is doing proprietary. Everybody is doing proprietary chargers. So what is happening with that is, if at all you look at the Bharath EV charging norms and few other things, it is always advisable to go for a higher voltage system setting, because that actually gives you more exposure to be able to use the existing infra in the place. So if you have a low voltage or a low power system in place, you would not be actually even using partially of what the charging infra is already in the market. So you wanted to make sure we can make the most of what is already there, and also be able to fast charge our systems at a higher voltage and a higher power setting. And also we are Bharath EV compliant. So this doesn't really have to have anything in against any other guys using anything. But whoever is Bharath EV compliant, even we are Bharath EV compliant. So just that our power side on the vehicle is a higher voltage, higher power side, but on the input side, it's all the Bharath EV same norms. So it's not a big deal.
Okay, fair enough. Again, sticking on to charger, again, I will go back to my friends in Bajaj and their Chetak. So they've got a very neat way of putting in the charging cable in the front area. So that's on my wish list. So we've got such a huge front area available. So कुछ तो जगह बना सकते हैं उसके लिए. What do you think?
Okay, so there are two things to answer this. First is that they are not practically Bharath EV compliant, because what is happening is that they have an onboard socket on the vehicle that is not compliant to Bharath EV C2 norms. So you would know that, obviously, right? They have an adapter that goes into a Bharath EV compliant charger. So you cannot use a Bharath EV compliant charger's port directly onto your vehicle on the thing you're talking about. Your friends at wherever it is. So they don't have the port that goes onto the vehicle. It's a normal IEC, the power adapter that comes in. I think it's the C13 charger port. I think that's basic, that comes in all the power electronics. So that is what goes onto the vehicle, and then the other side of that port is that goes into a Bharath EV compliant charger. In our case, the Bharath EV compliant charging port directly goes onto our vehicle, and that gives us a way more different, architecture on the electronics front, on the electrical front, and keeps us away from a lot of EMMC and EMMC compliance issues. So we wanted to have that port directly built on the vehicle to let go of a lot of different issues that are there in the market currently. That's why we have a IEC grade port onto the vehicle built itself. Now, so yeah, we could have done away with that same thing, but it would just end up increasing our hardware, and we don't want to do that. In our case, we have the port. Even if you want to charge from a normal socket, we have an accessory that we sell across as an additional charge with the vehicle that you can have. It's just like a normal cord that connects to your IC plug on the scooter, and then normal 15 ampere socket onto the wall. So we do have that accessory in place, but we wanted to follow the Bharath EV compliance to the maximum, and that's why we had the port also installed on the vehicle for sure.
Okay, lovely. One thing which again viewers would probably be interested in knowing, and Glyde versus Glyde SX or Glyde Plus, sorry. What are going to be the primary difference between the SX and the SX Plus? One, of course, is the speed. Anything else?
Speed is major. Also, you don't get the regen settings onto the Glyde SX versus the SX Plus. Also, you don't get the same, adrenaline rush that you would get, you go from 0 to 60 at that. So obviously, it's a low power scooter, so the power ratings are less. Yeah, there's one good pro to the SX is that the range is going to be very high. So you're claiming 130 currently, but it's going to definitely be more than that, because you would have seen our trend from the very beginning. We claim the lowest and give the high. We claim the lowest in the market currently. So in terms of the high speed scooter, we came only 100 kilometers ka SX Plus. So, but then the range is even more than that for sure. So the same way, even the SX the range is going to be good enough. So that's one thing that's a difference. Also, in terms of our specs, we have also limited a few of the smart features on the SX. We don't have geofencing on it. We do have AOIs, that's area of interest, but we don't have geofencing on the Glyde SX. In terms of the charging is very similar. We don't have obviously we don't have high. We only do 0 to 50% fast charging on the SX, but do 0 to 80 on the SX Plus. So there are a few things that we have limited on the SX versus SX Plus, but I think the
software is kind of what is kind of going to be differentiating.
Also the
companies also doing that.
Achha. Yeah, the drivetrain definitely is also a little bit different. So that has been done. So I think.
Right. Last question. बहुत सारे लोग कहते हैं कि भैया मोटरसाइकिल नहीं लॉन्च करके आपने अर्थ का अनर्थ कर दिया है. So just before you leave, Rushii, when are we going to see your lovely motorcycles coming out of your factory?
Right. So I think the motorcycles are going to be, so to give you an example, like as I mentioned earlier, also the delays have been because we are trying to streamline our production and stuff like that. And in amidst of that, just imagine launching one more product in the market and trying to produce the same with the scooters also in place. So it's going to just be 4 times more work at once, and we don't want to chew more than what we can eat. So I wanted to make sure that we go step by step. We did launch the vehicles together on the same day at the launch on 26th of January. But we wanted to make sure that, we know that we are going to bring it out very soon. But I think it's going to definitely be in second or third quarter of 2022 by default. We don't want to do anything earlier than that, because we want to make sure that we streamline our production and reach our critical mass of production per month, whatever we are expecting our targets are, and then shift on to getting a new vehicle into production and put our resources behind that. So you want to be very focused on one product, that's the SX and SX Plus at the third time, the scooters, and then shift to a newer genre of vehicle, that's the motorcycles. So so to just answer the question, it's just a matter of 2 more quarters to go about, and the motorcycles would hit the road. But it's just for the sake of convenience of the customer itself that we're not launching it at once, so that other expenses don't suffer.
Okay, Rushii. So I think that brings us to the end of the talk. Thank you so much for joining us, and I really look forward to having your vehicles and doing some rides here in Pune with that. And I'm sure next month onwards, we're sitting in December 2021 as we record this podcast. So from January, inshallah, we will have a lot of our viewers who will be sitting on your vehicles and doing test rides, and hopefully delivery soon after. So all the best to you and the team, right? And
thank you so much. And thanks for having me on the thanks for having me on the podcast the second time. Okay. Have a good day. Thank you so much, guys.